Hi everyone, welcome back to the channel, and today we will be discussing another problem from our DP section, and that is edit distance. So I'm sure a lot of you must have already gone through this question a lot of times. It's an important and a very nice question. Let me just check if I'm live yet. Yes, we are. Okay, so let's understand the problem statement. Very similar to what we have been doing for past two lectures, you can say. Okay, so you are given two strings S and T. Return minimum number of operations required to convert S to T. Okay, so an example here is geek gsec. Let me take it. Geek, and another one is GESEK. Okay guys, so what you have to do is that this is, let's say, string 1 and this is another string T. Okay, so I want to convert this string to this string, and in how many minimum operations can I do if I can perform total 3 kinds of operations at a time. One of these 3, what are those? Either I can insert a new element, that is I can insert a new character, I can delete that current character, and what else do we have? Insert, delete, and replace. Okay, and replace that character with the character that we want. So basically we have 3 options for every character. Now let's have a look, how can we do it? Let's say you can, again, as I'm saying, I start from here, for example, or we start from here completely. Okay, so when I am here actually, okay, G and G, I see that both the characters are matching. Okay, if the characters are matching, do I need to do any of these things? No. If it is matching, I do not need to perform any of these operations. I go to the next index, right? Now I am here. I see again whenever there is a match. So tell me, are you taking any step or are you performing any operation? No. Whenever there is a match, you perform 0 operation. Okay, no operations performed. So that, and basically you have to tell in how many minimum operations can you convert S to T. So as and when I am getting a matching character, I am moving ahead. Now I am at this character, and simultaneously you will move ahead in your next string as well. Now when I see there is a mismatch, okay, E does not match with S, so what would be the best operation to perform such that the number of operations stay minimum? So I cannot decide immediately by choosing one of the operations. I will go and check all the 3 operations. So for example, I started like this, geek, okay, and another one was gsec. Okay, so basically what I did was I was moving ahead when I found that both the characters are matching. 0 operation. Okay, no operation needed. You move to this string, your remaining string was this. Again the characters were matching, 0 operation. Okay, and your remaining character, remaining string becomes ek and sek, right? Now you again compare the first characters. See, I am repeating, you can try this approach from backside, that is you can try matching the characters from the end index and move towards 0. This is just for you to understand the recursion tree, visualize it, and up to you how you want to do, top down or bottom up. Okay, fine. Now when I am at this character, these characters are not matching. So the question now comes down to in how many minimum operations can I convert ek to basically sek. That's my operation. So when my question comes down to this, I will try all the 3 possibilities that I have with me. So the first possibility is, let's say I insert a new element. So if I would like to insert a new element, let's say for insert, this is for delete, whichever operation you perform, you are anyway going to have one operation, right? No matter whichever you do, one operation would be needed at least. Either I insert a new element, another one is I delete this element. So if I delete my element, my problem comes down to solving for k and sek, right? Because this is my delete operation. In my delete, what will I get? I will be comparing this. Let me not write here, let me just write the operation name. Okay, we will see what problem we'll be left with. Now third one is if I replace it. So if I replace it, we'll see what we can replace it with. Now, by performing these operations, tell me what my question will come down to. Now, if I insert a new element, if I'm talking about insertion, then I'll be inserting exactly at that index, right? So my problem becomes a new problem to solve for these two strings, right? I have to basically now find the minimum ways to match this string with this string. Here obviously they are matching, so you'll observe that even if you go down in the recursion tree, the number of operations are going to be 0 for this case. Okay, fine. If I delete my character, so basically my problem will come down to solving the same problem for two strings where first string is k, other one is sek. And if I replace this character, so obviously I would want to replace it with the character that I am seeing at 0th index in the other one. So I'll make it sk and other one will become sek. Now my problem will come down to solving for these different cases. As I go down in the recursion tree, the number of ways that it will give me will be 0. Basically, no more operations are required to match this string with this string. So whatever answer I got, obviously for this case, you will see the answer will be greater than 0 only. For the other cases, the answer will be greater than 0. Our aim is to get the minimum of all the answers. So for example, it gave me some answer 1, any integer answer 1. This, I'm not going ahead more in this recursion tree. It's going to be lot of cases. So the intent is for you to understand that what might be happening. So I get results from these three options, right? Whenever there is a mismatch, I have three options. Again, for example, when I am here, I have three options again. I go down in my recursion tree for all the three cases, same for this. So where from all the cases, the minimum answer that I'll get, I would like to select that answer. Since I know for this case the answer is going to be 0, so no matter how many they give, they cannot be a lesser value than 0. So I am already choosing that value to generate my answer. So when I take 0, this 0 I'll take for this case and add 1 to it. Basically this case will be returning its answer here with a value 1, right? Because 0 it got from its subsequent subtree, and for itself, because it was a mismatch, so obviously one operation was needed, right? And one operation to move to this step which gave you 0, right? So you added 1 to the answer you got as minimum from the subsequent subtrees. Now this will return 1 as its answer to this one, and since this was a match, right? So whenever there was a match and you move down in the bottom to the further subtree, you needed no operation to move to the next step, right? You needed no operation. There was 0 operation needed. Okay, so because whenever there is a match, you move to the next index. That's a simple iteration that is going ahead, but operation needed was none. So whatever minimum answer you got from your subsequent tree, you add 0 to it. And similarly, suppose what do we get? 1 plus 0, I think. Let me check what happened to it. Okay, yeah. So whatever answer we got from here so far, the minimum is 1. Okay, as I move up here, you know that it was a match, so I got answer 1 and I'll add 0 for myself because there was no operation needed. Now finally 1 will be returned to this case. In this case also there was a match of the characters. That is when we moved further in my recursion tree. So would you need any operation to add to the answer that you got so far? This is the minimum you got so far. No, there is no further operation needed. So finally your answer is 1. So this is to give you an idea what is happening recursively. But as you can see here, every character has 3 options. Suppose the length of this string is n, string is m. So you remember whenever we had 2 options of selecting and of not selecting and selecting, the time complexity used to be somewhere big of 2 to the power n because of the 2 options that every character is having, right? So 2 multiplied by 2 as number of characters or as number of steps I have to perform. That depends on the length of the array or string or whatsoever you are operating on. In this case we have 2 strings and each character has 3 options. So 3 into 3 into 3 like this n times, plus another similar thing for 3 into 3 into 3 goes up to, let's say, m times, right? So this is somewhere big of 3 to the power n plus 3 to the power m. So Definitely recursion is not, we are going to optimize the solution, and that's where we will reduce the calls that must be there will be overlapping sub calls. You know that we are evaluating similar answers a lot of times, same case must have been evaluating. So as we discuss, okay, before I move ahead, we are going to discuss the tabulation method. I would highly recommend that now, since you have understood the recursive approach, right, please try memoization yourself. Okay, it's nothing, obviously that is also an optimized approach, it will also take the same time complexity as tabulation. The thing is that you should understand the recursion also, what is going behind. With memoization, you will be taking an extra space of DP for sure, means DP array, whatever array you want to take, let's say 2D array, in which you will be making calls through recursion and storing your answers in your DP array. In tabulation, we won't be making any recursive calls, but we will be, since, see, why I recommend that always attempt the problem using memoization, then move to tabulation, because tabulation is not intuitive. Tabulation is something you will try when you actually uh, try to watch a video, or maybe try to learn from somewhere. It's not that intuitive. If you get it, very good, but entry is the first step for any DP problem for you to understand. So that is why please attempt it memoization way and then move to tabulation way. That's if you want to understand DP in depth. Okay, fine. So let's understand from tabulation what we actually want to do. So for example, if I take a string, like I'll take a smaller example, A, B, C, okay, and other string is, what can I take? A, very simple string I'm going to take, A, E, ATC. Okay, for example, I have two strings. Very clearly, you know the minimum operation for this is going to be 1. You just have to replace this string, this character with T, and you'll get your answer. There is no other way less than 1 in which you can convert ABC to ATC. So basically, minimum operations required to convert ABC to ATC would be 1. Okay, so let's see via tabulation how are we going to do it. So we have a table, let's say ABC, okay, and this is an empty string, same here, empty character ATC. What are we going to do here is that check if you guys are able to see me. Let me check if you guys are able to see me. Okay, let's just give me a moment. I'll just quickly try. Okay, so see, what does any cell represent? So for example, if I'm standing in this cell, so this tells me the value in this cell will tell me that the minimum number of operations that were needed to convert string AB. What is the character here? It's empty string. So in how many minimum operations did you convert AB to an empty string? That is what any cell would represent for that particular index. If I'm standing at this index, right, so this will tell me the number of operations needed to convert, minimum operations needed to convert. What is the string represented till this index? A. And the string represented till this index is A. So minimum operations in which you converted A to A, right? So this is what this question is typically about. Now let's start filling up and understand how we are going to do that. So I have an empty string. Wherever I have an empty string, you know that, see, I'll just show you. If I have A and another is an empty string, in how many minimum steps will you be converting A to an empty string, or vice versa? You'll delete it for sure, so one operation. And for example, if you have to convert empty string to A, so what operation will you perform? You cannot perform delete, you cannot perform replace, you can perform insert. So insert is again one operation. So either it's an empty string to one character or a character conversion to an empty string. Either way, whenever you find an empty string at one place, so the number of characters that are present in the non-empty string would be the number of operations that you will need to convert it to the other one. You getting my point? wherever one of the strings is an empty string, so the minimum number of operations to convert either of them to any one would be the number of characters present in the non-empty string. You can try it on your own and understand what I'm trying to say. So basically I will pre-fill this array, 2D array, for empty character indexes. If I want to fill this, an empty character converting to empty character will take 0 operation. Now I want to convert a to an empty string. This is what it represents. How many characters are in the non-empty string? 1. If I want to convert, if I'm at this position, this tells me number of operations needed to convert AB to an empty string, minimum operations. So number of characters in non-empty strings are 2. So 2 operations. Same for here. And now when I'm here, so empty character being converted to A will take 1 operation, because only 1 character is present in the non-empty string. Empty string getting converted to 80. This is what this index represents. So the string till here is 80. So how many characters are in 80? 2. So 2 operations will be needed. Similarly for here, 3 operations will be needed. Now let's start. Our actually calculation starts from this index. Okay. So this tells me how many operations I might need to convert A to A. Whenever there is a match, okay, that means you'll ask, if it's a match, so your problem comes down to what was the string after I remove these characters. So this is an empty string. So you'll go back, okay, you'll go back to the string by excluding these characters from their respective strings, and the answer that it will hold will be your answer. Okay, so because if it's a match, no operation was needed to convert this to this. Now I will see, what if, see, this is a character matching and we don't know what went before those characters, what was the string. So I want to gather the answer for the remaining part of the string, and that answer I'll get when I exclude both the characters, and excluding both the characters will be the answer that I'll get from the diagonal just above it. Why? Because this represents these strings excluding these characters in their subsequent S. This is S and this is T. Getting it? So answer what I get is 0. Okay. Now talking about this, whenever there is a mismatch, you have total 3 options. 1, so basically I am trying to compare AB with A. Okay, and your point of comparison here is you are comparing the last characters of the string that you have. You're trying to compare B with A. Since it's not a match, definitely 1 operation would be needed. But that 1 operation will be added to whatever answer your remaining string will give me. The minimum answer that I will get for the remaining part of the string I will add 1 to it, right? Now let's see what is the minimum that I have got if I exclude them or include. See what I'm trying to say. What are the possibilities? B and A are a mismatch. So you will ask, if I want to retain B, okay, if I want to retain B and exclude A, so what was the answer I got for this case? Okay, gather that answer. Anyway, I want the minimum of all the options. Other option is that you exclude B and ask that what was the answer when I got from this case. Okay, right, this is one, and the other one is I am missing. One is you are adding yourself. I don't know which one is it. Which one I took? I kept B, removal of this. One is removal of this. Okay. And the other one is, I think, insertion part. Okay. So, and these cases you will find, you'll get from this part will give you answer when you actually excluded yourself from S, right? So this is the answer you are getting from here. This answer is when you excluded, I am talking for here. So this is telling you the answer that you will get after excluding this character from T, right? So your question is for this and AB and the T is this. This is what you are getting from here. This tells you what is the answer that you get while excluding yourself, that is for A and A, right? Okay, and this tells you that when you excluded both the characters from each string, so here it was AB, now it becomes A, and here it becomes empty string. So of all the three cases, what is the minimum you got? You add 1 to that answer. Why? Because it's a mismatch. So anyway, one operation for you was needed. Just remember that recursion tree. So what is the minimum out of these three? 0, and you'll add 1 for yourself, so you'll get 1. Now we are going to repeat the same thing, considering if it's a match or a mismatch. A and C are also a mismatch, so you just take the minimum and add 1 to yourself. Okay, so it becomes 2. Ideally should have been 1. What am I doing wrong? Minimum. Something is not right here. A and B are a match. Let me check what went wrong. ABC, ATC, AA match, so 0. Okay. AB mismatch, so I took 0 and minimum 1. I did 1 to it. Let's see what is the answer that I'm going to. Let me fill it. 1, 2. From here it's a mismatch, 0, 1. From here it's a mismatch, 1. From here it's a mismatch, 2. Okay. From here I don't see answer getting 1, but let's see. Mismatch, so 2. It's a mismatch, 2. It's a match, 1. Yeah. See. So when I reached here, basically there was a match. I'm filling it in the same pattern as I told you. Whenever there's a mismatch, you take the minimum of all the three possibilities, which are typically these. Okay, for one particular case I told you, whenever there is a mismatch, you know you need no operation, so you'll directly take the minimum of the diagonal above you. So that's how finally we end up getting 1 in the last cell. So answer will be given to us by the last cell of this grid, because this tells you the minimum ways needed to convert ABC to ATC, right? So that is pretty much about it. As you can see, we are taking big O of m plus 1 into n plus 1 as a space, and same is your time complexity, right? So that is all about this question, and since explanation was the important part, code is simple. For tabulation is even more simple, nothing, just 2 loops running over these dp, and the formula that we just discussed, we are using it. So how, whenever there is a match, I am just taking the answer from the diagonal above it, which will be given to you by indexes I-1 and J-1 for obvious reasons, because we have discussed it a lot of times. So I am assuming that this is not something I should focus on enough. And whenever there is a mismatch, you are going to take the minimum of the 3 possibilities, right, and add 1 to that. Fine. So that's all about it. Okay, this is the minimum of 3 possibilities, and 1 for the operation that you will do because it's a mismatch. And finally you return the last index of your dp. That's what you are going to do. So that's all for today, everyone. It is an important question, and please do attempt it by both methods. Memorization is for you to understand the recursive approach, and then finally this tabulation is the easier one. Okay, fine then. If there are no doubts, I'll just wrap it up, and that was all for today, everyone. Thank you, and see you all in the next lecture. Bye bye and take care.